Going to look at homogeneous equations in this video. Now, a homogeneous equation has to be one where we have it as dy by dx equals a function of y over x. Always we're going to use this substitution. Okay, so let's just concentrate a minute on that substitution, because this is going to be common to every single one we do. That y equals x v. Differentiating both sides with respect to x gives me dy by dx, and using the chain rule, we will have v plus x dv by dx. Now we're going to be using that all the way through, because we're going to replace this dy by dx here with the v plus x dv by dx. Now it probably looks a little bit complicated at the beginning. One example and we'll be able to show how it works. Now these questions can be long, but they're not too complicated if we just follow through all the rules. So we can see that they've given us this substitution. We can see we've got dy by dx. Now the first thing I'm going to do is rearrange that so it's in the form of a homogeneous equation. So I can rewrite dy by dx again. It becomes x divided by x plus 2y divided by x. And because I've got this y divided by x part, I know it's homogeneous. Now y, that equals xv. We also know then that v equals y divided by x. And we can say that dy by dx is equal to v plus x dv by dx. So that's the part that I did in the first part. It's going to be the same for all of them. I'm going to go through that equation now, and I'm going to rewrite it. So I'm going to replace that dy by dx with v plus x dv by dx. And on the other side, I can see that I've got 1 plus 2 y over x, so it becomes 2v. We can take away that v from both sides. Let's just do this here on the other line. So x becomes dv by dx is equal to 1 plus v. Now I can separate my variables and I can integrate, and we're getting somewhere towards a final solution. So we then have dv 1 plus v is equal to dx over x. Integrating through, natural log 1 plus v equals natural log x plus c. I'm going to make that c log a, and then I can combine it to make it natural log ax. Okay, we can get rid of the logs. V equals ax minus 1. Once we've got to this stage, we can replace v. Let's just go back over here. You see that v is equal to y over x. So we can make this y over x. So I'm going to times both sides by x, like this. And this here would be my general solution with that constant in there. But they want us to find a particular solution, and that gave me the values of y is 3 over 2 when x is 2. So 2 squared is obviously 4, take away 2. Let's add 2 to both sides. So a is 7 over 8. And then my solution becomes 7 over 8 x squared minus x. And there's my particular solution. Now, it looks like quite a long process when you look at this. But in actual fact, it's just a matter of going through. Replace that dy by dx with this particular part here. Get your x plus 2y over x as a homogeneous equation with v's in them and get it ready so we can separate the variables and then just go through the process.